So Todd, if you want to start sharing your screen, and today you're going to be talking about MXNet, which is one of the most popular deep learning libraries out there, and how we can use it from Crystal. So
Yep.
yeah, whenever you're ready.
All right. I hope everyone can see the screen, and I hope everyone can hear me. I've managed to make it through this last year and a half or so without installing Zoom on anything except my phone. So I'm figuring out some of this as I go along. Leandro's talk was actually a perfect introduction to this, because some of what he and I think others that are dealing with data were dealing with was an environment that maybe wasn't exactly what they wanted, right? Lots of Python, great tools available in Python, but fundamentally, if Python's not your thing, for whatever reason, right, you're kind of not in a great situation, and that's where I was sitting as well. So what I wanted to do is talk to you just a little bit about MXNet.cr, which is a project that I've worked on. And I guess by way of leading into that, let me go ahead and just kind of give you a brief overview of what I'm going to talk about. Sorry, I've got my dog vying for my attention in the background here. So I want to spend just a couple minutes talking about the motivation of what I did, give a quick brief overview of MXNet, so just kind of visually people can understand what it's about. Talk a little bit about porting Python to Crystal, which was kind of the big learning opportunity for me, and then talk about a few lessons learned. I'll keep one eye on the clock, so we've got a little time for questions at the end of this thing. All right. So MXNet.cr is a set of language bindings to the Apache MXNet deep learning library. And it's also a port of Gluon, which is a deep learning kind of framework or toolkit over to Crystal as well. And it's also a little bit, and as I unravel the story a little bit, a port of a port. And that'll be clear what I mean about that in a second. So before I was working on Crystal, I had an interest in doing data science in Ruby, and there wasn't a ton available. I had been using Python, which is, it's a fine language, but it's just not really what I wanted to be using. I'd used Ruby for about 15 years prior to that. It's a language that I think is very ergonomic, and so I wanted to take advantage of that. But there wasn't an easy way to do the data science work that I wanted to do in Ruby. Until I stumbled across two things. One of those, and I did so about simultaneously, one of those was the Apache MXNet library, which once again is a library, but was designed to support multiple language bindings. They had Python, obviously, as kind of the reference implementation, but they supported Java and other languages as well, Perl, for instance. So it had the promise of allowing me to build something to Ruby. And then even better, I discovered MXNet.rb, which was a set of bindings by Kenta Murata to Ruby itself. And so for a while, that was great. I could actually sit and go through, and at that point in time, I was kind of refreshing my experience with deep learning and machine learning. So I was going through a particular tutorial, and I could make quite a bit of progress on that. Up until I hit a particular point. The tutorial I was going through was MXNet's Deep Learning is Straight Dope, which is a great introduction, I think anyway, because it ties to a particular toolkit, but it's actually just a nice, gentle introduction for people that are either trying to get into machine learning or just to refresh their understanding from years past, which is where I was sitting at. So I was kind of going through these, and I kept running into blocks because MXNet.rb didn't support Gluon, which was once again the framework, the higher level framework for building deep neural networks. So I did what would probably be the obvious thing in this situation. I decided I would just port Gluon from Python to Ruby, and so that's what I did. And for a while, I was pretty happy with that, and kept working along. So what you get with MXNet.rb and MXNet.cr are a set of tools for kind of dealing with arrays of various shapes, doing linear algebra with them in a pretty deep library of operations you can perform on them. So this concept of ND array, which is a multi-dimensional array, is kind of central to the language here. And I just wanted to paste up some of the syntax so you could kind of see what you were dealing with there. This was all is all in the Crystal version of it, but ultimately this was supported in Ruby at the time as well. And then there was this Gluon library as well. So Gluon, these all of this is fairly low level, right? What you want to do is think about building neural networks in terms of layers of blocks, right? If you're reading a paper and you're going to try to replicate what's in the paper, typically there's some diagrams outlining this particular neural network architecture, and you want to convert that into something at a relatively high level, not just glue all the pieces together bit by bit. And so that's the Gluon piece as well. So this low level array, an associated symbol for symbolic, the symbolic non-imperative computation, and this Gluon library are kind of the core pieces of MXNet. So what ended up happening was I built the Gluon for the Ruby version. A bunch of that actually got merged into MXNet RB. But at the time that it was getting merged in, I actually started shifting my attention away from Ruby to Crystal. It was about 2018, and I was pretty excited about what I was seeing. So I was a little bit late to the party, but late enough that what was going on was super interesting to me. I was excited about the performance. And so I no longer wanted to work on Ruby. I wanted to do things in Crystal. So I did once again the obvious thing, and I just ported everything from Ruby to Crystal, rewriting some of the lower level stuff that Kenta had done himself in Ruby, but doing it in Crystal. And that's kind of how we wound up with MXNet.cr, which is the Crystal version of that. So a big chunk of this story isn't so much about machine learning. It's really about the process of porting what amounts to a Python library into Ruby and then ultimately into Crystal, which is, I think, what was really interesting about this project to me. So one of the things that I was shooting for when I did this port the way I did was kind of a low cognitive price for, say, translating models, right? In particular, and just to be kind of clear about that, for somebody, say, going through the MXNet tutorial, which is where all the examples are in Python, I wanted to make it really easy for somebody to take those Python examples and very quickly and maybe almost mechanically convert them into running Ruby or running Crystal, right? And that's what I meant about a low cognitive price. You're in the process of learning machine learning. What you don't want to do is have to learn a lot of syntax transformation, kind of in the process. And I wanted to kind of highlight this because, once again, this is the last talk, I think, was a great introduction to machine learning and the kind of problems people are trying to solve. What I wanted to focus on a little bit is the interesting parts of doing this implementation. So this is kind of a Python versus Crystal picture of what I mean by, kind of ease of transformation, right? At the top, you've got Python. At the bottom, you've got Crystal. And you can see fairly easily the mapping from one to the other. This is creating a simple little function. And then what they're doing is kind of generating a bunch of points across that function. And then they're mixing in a little bit of noise, because in the example here from the Gluon tutorial or the MXNet tutorial, what they're going to try to do is kind of do a regression to figure out what the original function was. So anyway, you can see right here, it's a pretty small amount of difference from the language Python to the language Crystal. Here's another example. This is actually defining deep neural networks. So this is a few densely connected, fully connected layers of elements. And you can kind of see, once again, Python at the top, Crystal at the bottom, and syntactically, actually, the Crystal is very close to the Ruby piece as well. So once again, the goal is when you hit this in that tutorial, or if you're looking at a model that somebody's built, you want to fairly quickly be able to build that up in Crystal without having to necessarily kind of rethink your way through the translation from one framework or language to another. It doesn't always work so well, though. Here's a case where some of the intricacies of Crystal kind of get in the way of the implementation. Data loader in particular does a little bit of magic in figuring things out. We have to be a little more explicit about types. And then here's the kind of the core training loop for both cases as well. And if you look through that, you can see a lot of similarity from one to the other. Obviously, you've got the Crystal syntax, but the overall structure of running this training is pretty much the same. So what I want to do right now is just drop into, this is a super brief talk, so I wanted to just drop into a couple of the lessons learned that I thought were the most interesting about this MXNet.cr was actually the first large Crystal project that I did. So it's got a few warts, and I definitely learned a lot in doing it. Now, the thing that I thought was most interesting is that you can almost mechanically convert Ruby into Crystal in many, many cases. I actually started Crystal MXNet.cr by copying over all my Ruby files, renaming them, and then literally going through and just trying to fix the compilation problems. And you can see at the top Ruby and at the bottom Crystal, and literally except for like single quote, double quote, and method arguments, the code is actually identical, which you kind of hoped for going in, but didn't necessarily know if you could expect. And it's not this way throughout all the code, but it's an amazing amount of similarity from my perspective anyway, and I thought it was worth highlighting that. The other thing, and to kind of go back to Beta's comment earlier today, types are not always fun, and I'm pulling up that data loader example again to show you what it looked like in Ruby, and then what I had to do to get that thing to work with the magic it was trying to do under the covers in Crystal, right? So sometimes you run into types, and I think importing from Ruby or Python to Crystal, the types are what trip you up. And then very quickly, two other lessons learned that are probably no surprise for anyone that's done much Crystal work, but you can do an incredible amount with macros to reduce boilerplate. MXNet comes with a couple hundred low-level functions, and I was able to kind of dump all those out of the library and then use macros to create methods, objects and methods at compile time, which was great, and removed a ton of boilerplate. And then ultimately, obviously, Crystal has just absolutely first-class support for creating bindings to native libraries. A big chunk of the work in the Ruby side was, building extensions, and that was a horrible process, even though I've got a boatload of C in my background. And Crystal just makes this a non-issue. So that's it. I just wanted to put a screen up with a couple of links for people who are interested in looking at MXNet, the tutorial that goes along with it, or MXNet.cr, which is once again the bindings and implementation of Gluon. I'm not available on normal social network platforms, but if you're in the Fediverse, Mastodon, or whatever, you can find me at Epikistes below. So that's it. Happy to answer any questions here or later on.
Amazing timekeeping, Todd. Thank you very much for that, and very, very insightful presentation on the process of porting good code from Ruby to Crystal. So thanks for that. It's also a pleasure to have you here because we've had the opportunity to exchange PRs in the past, and I've been always very, very happy with that. So great to have you and to speak to you over Zoom. Meanwhile, lots of love for your background, Todd.
Thanks. It's not even virtual because I couldn't figure out how to do that. So